All right, so my history with JEA actually goes back. I started working as an engineering co-op when I was in school back in 1989, and I worked for the company as an employee until 2000. And then I've done projects for them over the years, the last 19 years. But JEA is located in Jacksonville, Florida, and it's the 8th largest electric utility, a municipal electric utility in the United States. And Jacksonville, Florida is actually, it's a consolidated government, so it includes the whole county. It's the largest, by square miles, largest city in the United States. But it's a big enough electric utility that got lots of juicy problems. About 20 years ago, they also took over the water and wastewater facilities from the city. So there's a lot of interesting problems to solve there, and this proof of concept that we've been working on, is going to be useful in all areas of the company. JEA's got a lot of the same pressures that I'm sure everybody in this room has. The consumers are, demanding more things. They're used to having a lot of automation in their house and stuff like that, and they want, more from the utility. Regulations and, environmental regulations, things like that are pressing. And, we're also a steward of community assets. And the mayor of Jacksonville, who's recently just reelected, has been asking questions about, does it make sense for us to be operating our own electric utility? Would we be better off selling it and divesting the assets and stuff like that? So there's, of course, a lot of pressure now on the management and the board to demonstrate value, which of course helps when you're trying to do new things. We got started down this project. This is actually a water problem, not a T&D problem, but it's probably very similar to some of the things that you have. Is that the COO of the company, was asking a question. She said, we got this water system. We know we're pumping water out of the aquifer. We're treating it. We're putting it into our distribution system, and we're putting more in than we're billing people for. Where's it going? There was actually a pretty interesting news thing a few years ago that this couple thought that they had a nice little natural spring in their backyard. And it turned out that it was actually, in the right-of-way, there was a leaking pipe back there, and it had been leaking for years. So, to solve this problem, of course, and I'm sure you guys have run into this same kind of thing, that you've got all these different systems that have different pieces of information. And to solve this problem, you got to start gathering all the information from all these different systems and making sense of it. And then there's also the critical part that we'll be talking about today, which is in the bottom right, which is that also we need to add some new sensors. We don't have enough instrumentation to completely solve the problem. We've got a lot of pieces, but there's some new things that we need to do. So, how do we get all this data and make sense of it? So this IoT project that we're doing is part of a larger initiative to start integrating the IT systems and all the information that's gathered across the organization to make it easier to solve those kind of problems. So today, if you need to solve that problem, you have to go to the SCADA system guys and go, how am I going to get the data out of your system? You have to go to the GIS and, okay, what's the format and how do I get it out? And you're doing a lot of work before you're ever even starting to work on the problem, and you have to kind of solve this every time you've got a problem like this. And it always degenerates down to there are a lot of systems where they just never really thought about the integration, or the vendor doesn't offer a whole lot, and it comes down to FTPing a CSV file and working on that. So currently they call it the accidental architecture, and it's like everybody else. You've got all these different systems that solve different problems, operational problems in the company, and you've got billing systems and all of that. But they were all put in to solve the very specific problems. They weren't really put together. Over the years, there's been data transfer and things like that, but it's a onesie-twosie thing that's done on each individual basis. So Michael Eaton, who's actually sponsors my project, he's the manager in charge of this. He's actually in charge of this much larger initiative to start to put together a database of, they're going to call it the foundation database, but a database of all the data structures. So they've got a data architect. They're going through each of the systems and figuring out what's stored in each one of them and coming up with a common language for describing it. And you know, our IoT project is going to plug into that. And there's a few slides later on where I'll kind of show you some of the implications of that and some of the things that we had to do to meet some of the demands. Kevin, when we were going over this, you know, I put the first Pi system in at JEA back in 1996. They've got about 300,000 tags, and you know, Pi is one of the, you know, I'm sure like it is at your company, when people have a problem, they start to think about, okay, well, how can I get the data into Pi? How can I look at it in Pi? So, you know, the OSI definitely would have liked to have had, you know, a nice Pi thing on there, but I grabbed this. The JEA is working with extensible, but Pi is definitely a big part of this architecture. So that gives you an idea of some of the drivers and how we got to this, like how we even started looking at the IoT stuff or why we thought we had to do it. And actually, so I guess we didn't get the latest version because I had a picture of a transformer explosion over there. So Michael actually has, yeah, so just imagine what the transformer looked like when it exploded. And I'm sure some of you being in the T&D track have seen that happen. So Michael is part of this initiative. He's actually got this spreadsheet, I think, of about 75 different opportunities for us to work on. From across the company, but the T&D guys actually had you know, the first thing that we could start working on. So of course, you know, they had a big transformer and it exploded, and it was probably about $1 million incident. So you know, the guys out in the switch yard said, well, you know, we've got these little sensors that we can put out there. We should be, you know, it's silly for us not to be monitoring these things better. And this is something that is happening all over the company, right? Is that, you know, people are having problems like this. They see that there are inexpensive sensors and things that, you know, you couldn't afford to do in the past, but now it's very, you know, accessible, and they want to go start bringing data in and solving these problems. So, you know, when we start looking at what we're going to do, you know, in the past, it's always, well, you go put it in and you put it in the SCADA system, right? Well, the SCADA system guys are getting kind of tired of that. You know, they don't want to put all these things that we're going to use for managing the assets on their operational system, and there's a lot of complications to doing that, of course, because you've got, you know, the NERC SIP requirements, you've got, you know, tag counts and licensing restrictions and stuff like that, and of course these are also mission critical systems, so they don't want you going adding stuff to it all the time, making changes and things like that. So that's where we come in, and you know, that's where we started looking at the IoT and the fog type platforms and said, you know, it really makes sense for us to build out a separate network so that we can put these sensors on there. You know, you go, if you were looking at the presentation yesterday, you know, they had the little Raspberry Pi with some sensors on it, right? So, I mean, you go into the SCADA guys and you got your little Raspberry Pi thing, and you got like your little Hello Kitty vibration monitor that you bought off eBay for $3, and, you know, they're totally appalled by it. And, you know, and I would be too. I mean, I've done enough PLC work that I know if I'm going to put a sensor on a PLC system, I want it to be a sensor that, you know, when the contractor backs into it with his truck, it messes up his truck, but my sensor still works. So these guys, you know, they didn't want it on their system, and we started thinking about, okay, let's build another system that's just for collecting this data, that we can kind of do things and be a little more fast and loose with it and make changes, and we're not going to affect the production networks. We're not going to, you know, make those guys nervous, and we're not going to cumber all of the change management and everything else. So Michael was at the conference last year, and we sat in on the Dianomic FogLAMP presentation. So Dianomic is a company that OSIsoft is actually invested in, and Pat Kennedy's on the board of it. And so, you know, I think OSIsoft's trying they've got two approaches, right? They've got the edge gateway that they're working on that's their product, that it's, you know, configurable, it's very, you know, OSIsoft-like. And then this is the open source that they're supporting. So you can actually go to GitHub, you download the source code for this, you compile it, and you can run it. But it's a microservice-based architecture, and it's open. So what we're hoping is that, you know, we'll be able to take this platform, and any of these vendors that are selling these sensors and putting stuff into a cloud and having a portal and all that kind of stuff, that we'll be able to get them to integrate the microservice architecture into their product and just send us data into our pipeline that we will have already established. So being open platform, we think, is crucial because, you know, when we can go to these different vendors and propose this to them, it's not a competitive thing for them. So if you think about this, basically think about it as like a small Pi interface that's just running in Linux. Okay, so you've got the southbound, the plugins that actually talk to the devices. It's got a little data storage engine, and it does the other things that you would expect a cloud or an edge platform to do. So it gives you, the capability to do alerting at the edge, and also to do some calculations, filtrations, things like that at the edge. But it's got a little data store, and it's right now I'm using the SQLite plugin, so it'll store the data just like a Pi buffer will, and then the northbound plugin sends the data upstream to whatever you want. So just to get started on this, I gave it a quick try. So I took a little Raspberry Pi, and I put FogLAMP on it, and set up an Ubuntu VM. And so when OSIsoft invested in this, one of the things that they did was they invested in it so that they could do the programming time to develop the plugins to talk to Pi. So getting this up and running, you can get it up and running and get data into your Pi system. It might take you a couple of days to figure it out just because it's new stuff, but you can get data into the Pi system pretty quickly. They've got a South plugin that does like the sinusoid generator, so it's just like the sinusoid tag in Pi, and you can get data into your Pi system, okay? So this was out of the box, and I've got a decent Linux background, and but it wasn't that big a deal to get it up and running. So, where do we run it so far? I've got it running in the Raspberry Pi. I've Dockerized it. I run it as a Docker container, and we're doing that because we think that's going to be crucial to managing all these devices. We're going to have all these edge devices, so being able to update FogLAMP, being able to update the plugins and stuff, we want to do it in Docker packages. I'm running it. I've got a Linux Ubuntu server and workstation, got it running natively and in Docker. And we've also put it up in an Amazon AWS Docker container. So, run on any kind of Linux platform really is where it's supposed to run. I'm working on some things now. Cisco, one of the things that JEA is doing is they're putting these Cisco IE 9000 industrial switches out there. That switch has actually got an Intel Xeon processor and 8 gigs of RAM. It runs Linux. It'll run Docker containers. I'm having some issues actually getting I'm probably doing the most complicated thing anybody's done on it. So I've got some guys up in Research Triangle Park, North Carolina at Cisco helping us out with this. We're working on it right now. They've also got some Schweitzer industrial computers out there, and I'm getting my hands on one of those hopefully next week to start looking at deploying it in there. So my goal again will be to get these platforms to support my Docker image so that I can roll it out. Dockerizing FogLAMP was pretty straightforward, and I actually I shared some of my stuff with some of the OSI folks. But I've actually got this on GitHub, so if anybody's interested, I'll give it to you and help you get it up and running pretty quick. Just an example. I don't know if anybody's ever used Docker, but it's pretty straightforward. I go get an Ubuntu Linux image. I start with it. I go get the utilities that I need to compile FogLAMP. I go grab FogLAMP off of GitHub. I build it and install it, and then it runs. So this is a condensed. I've cut out some stuff, but just to make it fit on the slide. But getting that up and running, it's fairly straightforward. There's some paradigm shifts, of course, when you start looking at the IoT stuff. Like I said, the whole idea behind the IoT is that you're doing things that are cheaper, faster and cheaper than what you're traditionally doing. It's opening up opportunities for you to do monitoring that otherwise, like in the past, you just couldn't afford to do. There was also some paradigm shifts that I had to go through, and some of my slides will show you a little bit more. But in Pi, we're used to a single tag, and it's got a timestamp and a value. Okay. In the IoT world, typically you're talking to some sort of an asset, and it supports just out of the box because of what the firmware does. It's got a certain set of readings. So these little B100 monitors that we have, I kind of cut this down, but this is what the data looks like that's coming through FogLAMP. So I got the asset as the Robinwood Transformer 1. The timestamp that the readings were taken, it generates a GUID key that it sends along with the data so that it can track stuff. But then I've got a series of readings, right? So when I was working with the data architect, I said, these IoT devices, when you buy them, it's whatever data they give you is whatever data they give you, and you're getting the readings in a packet. So it's a little different than what you're used to dealing with in Pi. What happens in the what happens when you're sending the data to Pi using the OMF gateway that they have built in is it actually breaks it down. So you've got, like Robinwood Transformer 1, LCT tank temp, so that it looks more like what you're doing. But it'll also populate AF, so you'll have the Robinwood Transformer 1 and attributes that say, what you're reading. But that was one of the paradigm shifts that I had to kind of wrap my hands around. Because this is open source, this isn't the out of the box, you kind of click and configure a few things in a GUI. I had to write a little code to get the B100 to work. The B100 supports Modbus, DNP3, and 61850. I chose Modbus just because it was simply the easiest one to get up and running. But the framework's actually built using Python, so there's Python and a bunch of C++ code. But to write the plugins, you can do them in Python or C++. I choose Python because it's the most productive programming environment I've ever worked with, and I've worked with pretty much everything. But this is a simplified version of it. But I go get the Pi Modbus packages. I go read the registers, decode them, scale them in the code, and then I pass the readings back into the FogLAMP pipeline. So once I pass them into the pipeline, they're stored in the buffer, and then they're forwarded on. So, don't let the plugins scare you. How many folks in here do any kind of Python programming? Is there anybody? Few? Oh, it's quite a few of you, right? So, if you know Python, it's kind of a superpower, right? It's amazing what you can do. So there's Python libraries for the Modbus. There's good Python libraries for DNP3. When you get to 61850, I haven't found any good Python wrappers. There might be some out there. If anybody knows of any, please let me know. But for that, you're probably getting into having to do some more C++ type stuff. But the idea is we get this device, this B100. We'll probably put a couple hundred of them out in the field eventually. I'll write the plugin to go get the data from it, and then when you go configure it in the field, it's just a matter of giving it the IP address of the device, and it automatically starts stuffing the data into Pi. This is what we've got working right now. So I've got this little B100 edge device. I'm talking to it through Modbus at the bottom. I'm still running FogLAMP on the Raspberry Pi, but like I said, we're looking at getting it running in IOX. We're also looking at getting it to run on the Schweitzer relays. And there's any number of little Linux industrialized bricks, like a low-end one will run FogLAMP fine. So we've got a lot of options there for what we'll do. Then we've got an aggregator node, so it's another FogLAMP node that's actually just running in a VM right now. So we pass the data up from the edge node into what we call the aggregator node. So ultimately, we'll have a bunch of edge nodes and probably a couple of aggregator nodes with a load balancer, because it's just doing HTTP web API calls to pass the data up. And then we're going into a Kafka service bus. So Kafka is a publish, subscribe. It's an open source application as well. So we can dump the data into Kafka, and it sits in there. It's like a queue, but the data sits in there until you purge it. So once I push it into the Kafka service bus as a producer, it's sitting in there, waiting for the consumers to come get it. So I've got a consumer right now that goes and gets some of the readings, and they're going into Pi. I just recently got an OCS account, so I'm going to be putting the stuff into OCS, and I'm going to use the OMF format, the data format. Has anybody in here played with OMF or the Pi Relay? Okay, so a few of you have. And of course, they talked about that in the keynote, but one of the really nice things, I'm not only using it for this, but I'm deploying it a couple other places as well. That OMF message format, it's basically like you're just passing some JSON to the Pi Relay, and it allows you to get data into Pi for free. So if you've got some of these ancillary systems that you want to put Pi into, I'm working with a couple of vendors where we've basically told them, I sent them the OMF spec. I said, if you send me the data in this format, I can get it into Pi. OSI is more than happy to have you use up some of your Pi tags, some of your licensed Pi tags using the relay for free. So that's what we've got going so far. So I alluded to this foundation database earlier. And so one of the problems I'm going to run into is that JEA, they're not an enterprise partner, so they've got 300,000 tag Pi system, and I'm getting ready to generate a whole lot of data here. So we've got some of the most important data, of course, is going to go into the Pi server, and we've already set some stuff up, and we're doing notifications and stuff like that, and they're happy with that. But some of the data is going to go elsewhere, and so that B100 may give me 20 readings. 2 of them will go to the Pi server. The other 18 I don't want to throw out. I got to find a place to put them. The OCS, Laurent Garrick, who did a presentation on that yesterday, and he gave us a little insight into what the commercial terms on that are going to be. And basically, it's going to be free to stuff data in there, and they're going to charge you when you read it. So it's going to be a great place to just go stuff a bunch of data that you're not quite sure what you're going to do with it yet, but you want to keep it around. So we're going to have that up and running hopefully before too much longer. So upcoming, of course, we're going to, in Kafka, I kind of glossed over that a little bit, but so in Kafka, you split things up, you make a topic, and so it basically just sets up a bunch of queues. So I've got a topic called IoT readings that I'm shooting all the IoT readings in. I'm also working on doing notifications from the edge. We're doing notifications in Pi right now, but we also want the edge devices to be able to send notifications, so I'm also working on having notifications, have the FogLAMP node at the edge generate a notification that'll be sent into another topic in Kafka, and then we can have things consume it. So, but that's, I've also got, they're getting me some more devices, so I'm going to be doing some more plugins. That first plugin, I probably spent about a day just working on it because I hadn't worked with that Pi Modbus module before. But now that I've got that, most of these devices that we're going to be doing in Modbus, I don't expect it to take very long to build the plugins for those. And we've also got some ideas for some more complex use cases. I know we've got some vibration equipment that we'll be sending up like RMS values in the data stream. But when an event happens, we want to go capture that event time frame in more detail and then process it through the stream. Right now, somebody has to go out with a laptop and get it, and then that data is just sitting on the hard drive of that laptop. So we want to go put it someplace where we've got it cataloged. So I'd like to talk a little bit too about some of the things that we've run into just organizationally and some of the challenges of this. Of course, we're doing kind of R&D type work here, and so Michael had to go push to get me access, to get me a workstation with administrator access and Hyper-V and Docker and all that kind of stuff. And then I'm hitting the Python package repository and Docker Hub to download images and all this stuff. So the network security guy who's been a friend of mine for 20 years, he knows enough to keep an eye on me. he trusts me, but he keeps an eye on me. But Michael had to really push for that, and there's been some things in the organization that have just kind of doing this kind of work that traditionally hasn't been done in the utility. So there's been some challenges with that, and I know like I'm talking about the Dianomic stuff. The reason Michael's not here is he got a new boss and who scheduled a bunch of stuff for this week. But there's a possibility also that we might be looking at some other frameworks and things like that. So there's a lot of challenges, but for you guys as engineers and people that are in this industry, like you can go download FogLAMP, get it working in a little Raspberry Pi. You maybe get you $60 worth of hardware and start playing with it. And if you haven't started playing with Linux, if you haven't started doing some programming in Python and stuff like that, those are going to be skills that you're going to need in this IoT environment, in any IoT environment. I don't think it really matters what framework you pick, or even if you pick a vendor that's trying to package it. I think you're going to get down to having to be able to do some of the low-level stuff yourself. So that's some of the challenges that we've run into. But that gets me to the end. And does anybody have any questions, comments?
If we can state, is this on? Yeah, state your name and company. And we've got, question over here.
Hi, Santosh. I'm from Georgia Pacific. Has nothing to do with transmission. Okay. But I was interested in the IIoT framework. So the question I had was, when you have IIoT devices and aggregators, you're going to send data to multiple destinations. Pi is one of those destinations, yes. But you have multiple other cloud platforms and destinations. Yep. So when you, MQTT is currently a universal protocol, which a lot of platforms use. So where do you advise to have your format? The OMF is a very specific, it's JSON, but it's a very specific format. Yeah. So do you, where do you advise to have the format specified, is it at the edge, the node level itself, or at a higher aggregate level?
Yeah, so no, so that would actually be the aggregator node that's pushing it into the Kafka bus right there. That's, oh, okay. The center, okay. So the data's coming up through here. It's coming up in the FogLAMP format that I showed you on the slide before. The consumer right here is where we're doing the OMF. Yeah, so that's specifically, and the nice thing is that OMF is used by the cloud services as well. So basically, it's going to be very similar code going to both places. And that was another good thing about, choosing the OMF format. But yeah, so this right here is just basically doing HTTP, HTTP put calls to the Pi relay to get it in there.
Thank you.
Any other questions? Got one right up here.
Hey, Robert. Call me old-fashioned, but is there a reason why you don't just use, sorry? Name and company. So I'm Tim Lucy from Energy Queensland. I'm presenting later. Is there a reason you don't just use a terminal server and a Modbus Pi interface to talk to these devices? Is it a question of scale?
Yeah. So one of the things is this right here. So yeah, you could put a Modbus interface and go do this. We're going to have this. I mean, for this particular implementation, we're going to have it at different substations. But we're also going to have these things, in the water and wastewater, and they're going to be all over the place. So the thing with doing the traditional Pi interface is that you'd have to have a Windows machine, and you want to have buffering as close to the data source as you can get it, so that if there's a communication loss, you're not losing the data. So this allows me to very inexpensively put buffers all over the place that are very close to the sensor and buffer the data. So I think it's going to be more reliable, and it'll be easier to support these things and pushing out Docker containers to these little devices versus trying to maintain a bunch of Windows machines and, of course, the licensing and all that stuff. So, that's what we're thinking. And then also, like some of these things are probably going to be provided by other vendors, who are going to come in and under contract do a system. And we want to be able to point them to this open source framework that they can implement to send data into our system, so that they can do whatever they're doing for their other customers. A lot of them are pushing things to AWS, and then they have like a little portal, a little dashboard that you log into and stuff like that. But that doesn't get data into the enterprise structure so that you can solve the problems later on. So, what we're hoping, like I said, is that just because this is open source, that it's kind of a non-competitive thing that we can say, hey, it's not that big a deal for you to put this on your devices. All of them are going to be Linux anyway. Please give us the data, and, please push the data into this system so that we can get it, we can get it into Pi and wherever else we want to do, and do the alerts and all the stuff that everybody's looking to do. We'll already have that problem solved. So it'll just be a matter of stuffing the data in. Anybody else?
Anybody else? So, Rob, my wife calls me Mr. 85% for all the projects I do at home. Mm-hmm. If I only missed that one picture of the transformer on your presentation, she's really impressed with me today. So I may get that gold star after all, unless you tell me that I missed 5 slides.
No. I think we got it.
All right. With that, thank you, Rob.
All right.